A V12 engine is a V-engine with 12 cylinders mounted on the crankcase in two banks of 6 cylinders each, usually but not always at a 60 degrees angle to each other, with all 12 pistons driving a common crankshaft. Since each cylinder bank is essentially a straight 6 which is by itself in both primary and secondary balance, a V12 inherits perfect primary and secondary balance no matter which V-angle is used, and therefore it needs no balance shafts. A 4-stroke 12-cylinder engine has an even firing order if cylinders fire every 60 degrees of crankshaft rotation, so a V12 with cylinder banks at 60 degrees or 180 degrees will have even firing intervals without using split crankpins. By using split crankpins or ignoring minor vibrations, any V-angle is possible. The 180 degrees configuration is usually referred to as a flat 12 engine, or a boxer, although it is in reality a 180 degrees V since the pistons can and normally do use shared crankpins. It may also be written as V12, although this is less common. Applications. These engines deliver power pulses more often than engines with 6 or 8 cylinders, and the power pulses have triple overlap. At any time 3 cylinders are on different stages of the same power stroke, which eliminates gaps between power pulses and allows for greater refinement and smoothness in a luxury car engine, at the expense of much greater cost, complexity and friction losses. In a racing car engine, the rotating parts of a V12 can be made much lighter than a V8 of similar displacement with a crossplane crankshaft because there is no need to use heavy counterweights on the crankshaft and less need for the inertial mass in a flywheel to smooth out the power delivery, and each piston can be smaller, lighter, and with a shorter stroke. Exhaust system tuning is also much more difficult on a crossplane V8 than a V12, so racing cars with V8 engines often use a complicated bundle of snakes exhaust system, or a flat plane crankshaft which causes severe engine vibration and noise. This is not important in a race car if all-out performance is the only goal. Since cost and fuel economy are usually important even in luxury and racing cars, the V12 has been largely phased out in favor of engines with fewer cylinders. Engines are often designed around cylinder units of a certain design size, shape and speed. These are used as the working base of an engine, often of 6 cylinders. If more power is needed, it is easier to simply add more cylinders to increase displacement, without having to design a newer, larger cylinder and head for each engine size. Thus locomotive and marine engines like the EMD 567 come in V6 to V24 versions, all sharing the same 567 cubic inch cylinder displacement and cylinder heads. Engines are also limited by the size of the cylinder bore and stroke. While one can increase the size of an engine by simply increasing the bore and/or stroke of the cylinder, a too large bore hurts efficient combustion, and makes for a heavy reciprocating piston mass, which limits maximum engine speed and thus power output. In a similar vein, increasing the stroke means the piston speed must be increased to match the same revolutions per minute, and this also limits the maximum size of an engine in a given weight-size range. These factors make it more feasible to build an engine of 12 cylinders and 40 liters displacement than an engine of 6 cylinders and the same size, which would have pistons too large and a stroke too long to meet the same RPM and power requirements, although it would make more torque than the 12-cylinder. In a large displacement, high-power engine, a 60 degrees V12 fits into a longer and narrower space than a V8 and most other V configurations, which is a problem in modern cars, but less so in heavy trucks, and seldom a problem in large stationary engines. The V12 is common in locomotive and tank engines, where high power is required, but the width of the engine is constrained by tight railway clearances or street widths, while the length of the vehicle is more flexible. It is often used in marine engines where great power is required, and the hull width is limited, but a longer vessel allows faster hull speed. In twin-propeller boats, two V12 engines can be narrow enough to sit side by side, while three V12 engines are sometimes used in high-speed three-propeller configurations. Large, fast cruise ships can have 6 or more V12 engines. In historic piston-engine fighter and bomber aircraft, the long, narrow V12 configuration used in high-performance aircraft made them more streamlined than other engines, particularly the short, wide radial engine. During World War II, the power of fighter engines was stepped up to extreme levels using multi-speed superchargers and ultra-high octane gasoline, so the extreme smoothness of the V12 prevented the powerful engines from tearing apart the light airframes of fighters. After World War II, the compact, more powerful, and vibration-free turboprop and turbojet engines replaced the V12 in aircraft applications. Early, pre-World War I, V12 engines. Marine engines. The first V-type engine, a two-cylinder V-twin, was built in 1889 by Daimler, to a design by Wilhelm Maybach. By 1903 V8 engines were being produced for motor boat racing by the Société Antoinette to designs by Léon Levavasseur, building on experience gained with inline four-cylinder engines. In 1904, the Putney Motor Works completed a new fifth 12 marine racing engine, the first V12 engine produced for any purpose. Known as the Craig Dorvald engine after Putney's founding partners, the engine mounted pairs of L-head cylinders at a 90-degree included angle on an aluminium crankcase, using the same cylinder pairs that powered the company's standard two-cylinder car. A single camshaft mounted in the central V operated the valves directly. As in many marine engines, the camshaft could be slid longitudinally to engage a second set of cams, giving valve timing that reversed the engine's rotation to achieve astern propulsion. Starting is by pumping a charge into each cylinder and switching on the tremblor coils. A sliding camshaft gave direct reversing. The camshaft has fluted webs and main bearings in graduated thickness from the largest at the flywheel end, displacing 1,120 cu in 18.4 L bore and stroke of 4.875 in × 5 in 124 mm × 127 mm. The engine weighed 950 pounds (430 kilograms) and developed 150 bhp (110 kilowatts). Little is known of the engine's achievements in the 40-foot hull for which it was intended, while using the engine to power heavy freight vehicles was not realized. One-fifth 12 Dorvald marine engine was found still running in a Hong Kong junk in the late 1960s. Two more V12s appeared in the 1909–1910 motorboat racing season. The Lamb Boat and Engine Company of Clinton, Iowa built a 1,559 cu in 25.55 L 5.25 in × 6 in 133 mm × 152 mm engine for the company's 32-foot Lamb IV. It weighed in at 2,114 pounds (959 kilograms). No weight is known for the massive 3,464 cu in 56.76 L 7 in × 7.5 in 178 mm × 191 mm F-head engine built by the Orleans Motor Company. Output is quoted as nearly 400 bhp, 300 kilowatts. By 1914, when Panhard built two 2,356 cu in 38.61 L 5 in × 10 in 127 mm × 254 mm engines with four-valve cylinder heads, the V12 was well established in motorboat racing. Motor car engines. In October 1913, Louis Coetailon, chief engineer of the Sunbeam Motor Car Company, entered a V12-powered car in the Brooklands short and long handicap races. The engine displaced 9L 550 cu in, with bore and stroke of 80 by 150 mm. An aluminum crankcase carried two blocks of 3 cylinders each along each side, with a 60-degree included angle. The cylinders were of iron, with integral cylinder heads with L-shaped combustion chambers. Inlet and exhaust valves were operated by a central camshaft. In the V-valve clearance was set by grinding the relevant parts, the engine lacking any easy means of adjustment. This pointed to Coetailon's ultimate aim of using the new V12 as an aero engine, where any adjustment method that could go wrong in flight was to be avoided. As initially built, the V12 was rated at 200 bhp 150 kilowatts at 2,400 revolutions per minute, weighing about 750 pounds 340 kilograms. The engine powered the car, named Toodles V for Coetailon's wife Olive's pet name, to several records in 1913 and 1914. Early aero engines. In 1909, Renault pioneered aero V12s with a 60-degree air-cooled engine with individual finned cylinders and F-head valve arrangement, driven by single camshaft in the crankcase. This was developed to a 12.2 L 740 cu in unit 96 by 140 mm, which weighed 350 kg 770 pounds and produced 138 bhp 103 kilowatts at 1,800 revolutions per minute. The propeller was driven from the nose of the camshaft in the central V, rather than from the crankshaft, thus providing an automatic half-speed reduction, improving propeller efficiency. Renault's designs were closely followed in Britain by the Royal Aircraft Factory. Its RAF4 engine displaced 13.2 L 810 cu in 100 by 140 mm, produced 140 bhp 100 kilowatts at 1,800 revolutions per minute, for a weight of 637 pounds 289 kilograms. Its RAF4A derivative was produced in substantial numbers during the war. By 1912, ABC Motors were offering a water-cooled engine of 17.4 L 1060 cu in, claimed to produce 170 bhp 130 kilowatts at 1,400 revolutions per minute and weigh 390 to 520 pounds 180 to 240 kilograms with radiator and coolant. In March 1914, Sunbeam exhibited an airborne version of Toodles V's engine at Olympia. Racing in 1913 had helped to prove the design, and encouraged a 10 mm increase in bore to 90 mm, the stroke remaining at 150 mm. Its rated output was 225 bhp 168 kilowatts at 2,000 revolutions per minute. Named the Mohawk, the engine was the most powerful available to British aviation at the outbreak of World War I. During the war, further enlargement to 100 by 150 mm created the 240 bhp 180 kilowatts Gurkha. Later V12s in aviation. By the end of World War I, V12s were well established in aviation, powering some of the newest and largest fighters and bombers and being produced by companies such as Renault and Sunbeam. Many Zeppelins had 12-cylinder engines from German manufacturers Maybach and Daimler. Austro-Daimler of the Austro-Hungarian Empire, produced also V12, designed by Ferdinand Porsche, with first 300 and later 345 horsepower, used with the big flying boats of the Naval Air Force. Various U.S. companies produced the Liberty L-12. Soon after the end of World War I, V-12 engines powered the first transatlantic crossings by the Curtiss NC flying boats 4X Liberty L-12, the first non-stop crossing by Alcock and Brown in a Vickers Vimy 2 times Rolls-Royce Eagles, and the first airship crossing by HM airship R-34 5 times Sunbeam Maori. V-12 engines reached their apogee during World War II. Fighters and bombers used V-12 engines such as the British Rolls-Royce Merlin and Griffon, the Soviet Klimov VK-107 and Miquelin AM-38, the American Allison V-1710, or the German Daimler-Benz DB600 series and Junkers Jumo. These engines generated about 1,000 horsepower (750 kilowatts) at the beginning of the war and above 1,500 horsepower (1,100 kilowatts) at their ultimate evolution stage. The German DB605 DC engine reached 2,000 horsepower (1,500 kilowatts) with methanol, water injection called MW50 equipment. In contrast to most Allied V-12s, the engines built in Germany by Daimler-Benz, Junkers Jumo, and Argus AS 410 and AS 411 were primarily inverted, which had the advantages of lower centers of gravity and improved pilot visibility for single-engine designs. Only the pre-war origin BMW V-12 of Germany was an upright engine. The United States had the experimental Continental IV-1430 inverted V-12 engine under development, with a higher power-to-weight ratio than any of the initial versions of the German WW2 inverted V-12s, but was never developed to production status, with only 23 examples of the Continental inverted V-12 ever being built. The only American design inverted V-12 engine of any type to see even limited service in World War II was the air-cooled Ranger V-770, which found use in stateside-based training aircraft like the Fairchild at 21-gunner twin-engined advanced trainer. The Rolls-Royce Merlin V-12 powered the Hawker Hurricane and Supermarine Spitfire fighters that played a vital role in Britain's victory in the Battle of Britain. The long, narrow configuration of the V-12 contributed to good aerodynamics, while its smoothness allowed its use with relatively light and fragile airframes. The Merlin was also used in the Avro Lancaster and de Havilland Mosquito bombers. In the United States, the Packard Motor Company was licensed by Rolls-Royce to produce the Merlin as the Packard V1650 for use in the North American P-51 Mustang. It was also incorporated into some models of the Curtiss P-40, specifically the P-40F and P-40L. Packard Merlins powered Canadian-built Hurricane, Lancaster, and Mosquito aircraft, as well as the UK-built Spitfire Mark 16, which was otherwise the same as the Mark 9 with its British-built Merlin. The Allison V1710 was the only indigenous U.S.-developed V-12 liquid-cooled engine to see service during World War II. A sturdy design, it lacked an advanced mechanical supercharger until 1943. Although versions with a turbosupercharger provided excellent performance at high altitude in the Lockheed P-38 Lightning, the turbosupercharger and its ductwork were too bulky to fit into typical single-engine fighters. While a good performer at low altitudes, without adequate supercharging, the Allison's high-altitude performance was lacking. After World War II, V-12 engines became generally obsolete in aircraft due to the introduction of turbojet and turboprop engines that had more power for their weight, and fewer complications. V-12 road cars. In automobiles, V-12 engines have not been common due to their complexity, cost and heavy fuel consumption. They are used almost exclusively in expensive sports and luxury cars because of their power, smoother operation and distinctive sound. Prior to World War II, 12-cylinder engines were found in many luxury models, including cars from Packard 1916 to 1923 and again from 1932 to 1939, Daimler 1926 to 1937, Hispano-Suiza 1931, Cadillac 1931, Auburn 1932, Franklin 1932, Lincoln 1932 to 1942, continuing after the war through 1948, Rolls-Royce 1936, and Pierce Arrow also 1936. Vehicles with 8, 12, and 16 cylinders provide higher levels of refinement compared to those with fewer cylinders, especially important prior to the general adoption of vibration-isolating engine mounts in the 1930s. Packard's 1916 Twin Six is widely regarded as the first production V12 automobile engine. With a list price of $1,000, the Auburn was the lowest-priced V12 car ever, unadjusted for inflation. Production cost savings were achieved by using horizontal valves which, however, did not result in an efficient and powerful combustion chamber. Between 1916 and 1921, there was a vogue of V12s, during which National Indianapolis copied the Packard engine, and Widely Motors, also of Indianapolis, offered a proprietary engine. Soon after the end of World War I, Lancia offered a 22° V12, Fiat had a 60° Model 520 1921-2, British truck manufacturer Ensign announced a V12 that did not materialize, and in 1926, Daimler Britain offered the first of a full range of sleeve valve double sixes, 7,136 cc, 3,744 cc, 5,296 cc and 6,511 cc versions remaining available until 1937. In 1927 more entered the market from Cadillac, Franklin, Hispano-Suiza, Porsche, Lagonda, Maybach, Packard, Rolls, Tatra, Voisin, and Walter offering V12 engines. Cadillac from 1930 to 1940 and Marmon 1931 to 33 even developed V16 engines. Improvements in combustion chamber design and piston form enabled lighter V8 engines to surpass the V12 in power starting from the 1930s. Only the smaller H-series Lincoln V12 remained after World War II and it was replaced by a V8 in 1949. Similarly, as they seemed excessive for the post-war market in Europe, production of V12-engined cars was very limited until the 1960s. Ferrari has traditionally reserved their top V12 engine for their top-of-the-line luxury sports coupes since 1949. Ferrari's closest rival, Lamborghini, has also used the V12 configuration for many of its road cars since the company's inception in 1963. In 1972, Jaguar introduced the XJ12, equipped with a 5.3-liter V12, which continued after revisions in 1993 until the 1996 model year, after which the marque discontinued the 12-cylinder engine. BMW returned to V12 designs for its 7 Series sedan in model year 1986, forcing Mercedes-Benz to follow suit in 1991. While BMW sells far fewer V12-engined 7 Series vehicles than V8 versions, the V12 is marketed in the US, China, and Russia. The BMW-designed V12 is used in Rolls-Royce cars, while the Mercedes engine was installed in Maybach cars. Mercedes S65 AMG, CL65 AMG, and SL65 AMG are powered by a V12 bi-turbo engine making 463 kilowatts, 621 horsepower, and 1000 Nm, 740 pound-feet at 2300 to 4300 revolutions per minute. The CL65 AMG has a significant higher cost, but the V12 engine makes them a status symbol. The V12 engine is generally smoother than the other 12-cylinder configuration, the W12, although the W12 is more compact. In 1997, Toyota equipped the Century limousine with a 5.0 LDOHC V12 model number 1GZ Fei, making it the first and only Japanese production passenger car so equipped. TVR made and tested a 7.7L V12 called the Speed 12, but the project ended. The only British marques currently using a V12 configuration are Aston Martin, whose Cosworth-developed engine was authorised during the company's ownership by Ford Motor Company, and Rolls-Royce. In 2009, China FAW Group equipped their Hongqi HQE with a 6.0 LDOHC V12 model #CA12VG, making it the first and only Chinese production passenger car so equipped. Most production V12 engines in road cars have an even firing order, with the uneven firing exceptions such as Aston Martin 5.9L V12 and Mercedes-Benz M275 AMG V12s. In 2008, Audi launched their Q7 model with a 5.9-litre V12 twin-turbo diesel engine, making it the first production passenger car so equipped. The engine also appeared in the R8 V12 TDI concept car. Post-war V12 production cars. This is a list of V12 engine production road cars produced since 1945, sorted alphabetically by make and sub-sorted by year of introduction. Some tuner companies, such as Brabus, also sell V12 versions of the Mercedes-Benz E-Class and CLS, which were the fastest street-legal sedans upon their respective introductions. Prototypes, custom-made with V12 engines. Heavy trucks. Tatra used a 17.6L 1070 cu in air-cooled naturally aspirated V12 diesel engine in many of their trucks, for instance, the Tatra T813, and uses 19L air-cooled naturally aspirated or turbo V12 diesel engine in Tatra T815. Some large trucks have been fitted with twin V12s that drive a common shaft, although this is often advertised as a V24. GMC produced a large gasoline-burning V12 from 1960 to 1965 for trucks, the Twin 6. It was basically GMC's large-capacity truck 351 V6, doubled, with 4 rocker covers and 4 exhaust manifolds. 56 major parts are interchangeable between the Twin 6 and all other GMC V6 engines to provide greater parts availability and standardization. Its engine displacement was 702 cu in 11.50 L, and while power was not too impressive at 250 horsepower, 190 kilowatts, torque was 585 pound-feet, 793 Nm. For firetrucks, the rev limiter was increased to produce 299 horsepower, 223 kilowatts at 3000 revolutions per minute, and torque was increased to 630 pound-feet, 850 Nm at 1600 to 1900 revolutions per minute. It was possibly the last gasoline engine used in heavy trucks in the US. Fire apparatus manufacturer Seagrave used 2 versions of the Pierce Arrow V12 motor starting in 1935. After Pierce Arrow ended production in 1938, Seagrave bought the machine tools and continued to build and offer these engines until 1970. American La France, beginning in 1931, also offered apparatus with a series of V12 motors built by ALF but developed from the Lycoming BB motor. Both manufacturers stopped offering a V12 option when fire departments began specifying diesel engines in their orders. Detroit Diesel produced their Series 53, 71, 92, and 149 engines as V12s, among other configurations. Auto racing. V12 engines used to be common in Formula One and endurance racing. From 1964 to 1980, Ferrari, Westlake, Honda, BRM, Maserati, Matra, Delahaye, Peugeot, Delage, Alfa Romeo, Lamborghini, and Tecno used 12-cylinder engines in Formula One, either V12 or flat 12. The last V12 engine used in Formula One was the Ferrari 044, on the Ferrari 412 T2 cars driven by Gene Alesi and Gerhard Berger in 1995. In the late 1960s, Nissan used a V12 in the Japanese Grand Prix and again in the early 1990s Group C races. At the Paris Motor Show 2006, Peugeot presented a new racing car, as well as a luxury saloon concept car, both called 908 HDI FAP and 908 RC, and fitted with a V12 diesel engine producing around or even surpassing 700 PS, 515 kilowatts, 690 horsepower. This took part in the 24 Hours of Le Mans 2007 race, coming in second place after the similarly conceived Audi R10 TDI V12 diesel originally developed for the 2006 season. Large diesel engines. V12 is a common configuration for large diesel engines. Most are available with differing numbers of cylinders in V configuration to offer a range of power ratings. Many diesel locomotives have V12 engines. Examples include the 3,200 horsepower (2.39 megawatts) 12 to 710 from Electro-Motive Diesel and the 4,400 horsepower (3.28 megawatts) GE V012 from GE Transportation. Large V12 engines are also common in ships. For example, Wärtsilä offers V12 engines with various cylinder bore diameters between 26 and 50 cm 10 and 20 in with power output ranging from 4,080 to 14,400 kilowatts 5,470 to 19,310 horsepower. These engines are commonly used especially in cruise ships, which may have up to 6 such main engines. The largest medium-speed diesel engine, Wärtsilä 64, was also offered in V configuration, and a single 1.2 V64 prototype with an output of 23,280 kilowatts (31,220 horsepower) was produced for an experimental power plant in the late 1990s. Topic: Railway V12 diesel engines specs. Railway diesel engines with 12-cylinder developing 500 kilowatts, 680 PS, 671 horsepower and more. Topic: Tanks and other AFVs. The V12 is a common configuration for tank and other armored fighting vehicles (AFVs). Some examples are German Maybach HL120 gasoline engine, used on World War II PZKPFW-3 and PZKPFW-IV tanks. British Rolls-Royce Meteor gasoline engine, derived from the Merlin Aero engine, used on World War II Cromwell and Comet tanks and the post-World War II Centurion and Conqueror tanks. Russian V2 V-2 V12 diesel engine, used on World War II T-34, KV-1, KV-2 and IS-2 tanks. Most modern Russian diesel engines for MBTs goes back to V2 base design. American Continental AV1790 engine, produced in gasoline and diesel variants, used on all versions of the Patton tank and on the M103 heavy tank. One of these engines was used to power a hot rod style car called the Blastoline Special. The 26.6-liter Perkins diesel engine in the Challenger 2 main battle tank and its variants.